Two boats leave a marina at the same time. The first boat travels 6 knots, or nautical miles per hour, at a bearing of north 39 degrees east, and the second boat travels 4 knots at a bearing of south 87 degrees west. Draw and label a diagram to model the situation. A. How far apart are the boats at the end of 2 hours? And B. What is the bearing from the first boat to the second boat at that time? So two boats leave a marina. So I'll have A as the marina. And I'm going to go ahead and draw my compass, NESW. And the first boat leaves at a bearing of north 39 degrees east. So northeast and 39 degrees. So I'm going to draw my north-south line. North 39 degrees east, this direction. So 39 degrees is this angle in here. The second boat travels 4 knots at a bearing of south 87 degrees west. So this direction here, 87 degrees. So I'll draw this angle, and 87 degrees is right here. So we want to see how far apart are the boats at the end of 2 hours. So I'm going to connect those here. So I have A, B, and C. And so let's label some side information. The first boat travels 6 knots. So this is the first boat. 6 knots, and we're talking about 2 hours. So 6 times 2, the total distance is 12 nautical miles, versus the second boat travels 4 knots. So 4 times 2, that total distance is 8 nautical miles or knots. So we want to find how far apart are the boats. So I'm going to call this A, and then we have B over here and C over here. So we are close. We are just missing the angle right in here. So we could have the angle inside this triangle. Well, we have 87 degrees here, and we have the north-south line. So we can actually just find the supplemental angle, and then that will help us to be able to know what is the angle here at angle A. So we take 180 degrees minus 87 degrees. We would find that that is 93 degrees. So 93 degrees. So if we add 93 and 39 degrees, 93 plus 39 will equal 132 degrees for angle A. So A is 132 degrees. So we have side, angle, side, and so we want to find the opposite side. We can use law of cosines. A equals the square root of 8 squared plus 12 squared minus 2 times 8 times 12, cosine of our angle of 132 degrees. So if you plug that into the calculator, we would get approximately 18.34 nautical miles apart, or you can always say knots as well. So this is 18.34. Now it says to find the bearing from the first boat to the second boat. So let me go ahead and draw a vertical line here. So bearing is to the y-axis here. And so the angle that we want to find, if I zoom in a little bit, so it's from this green line from B to our boat down there at C. We're looking at this green line here. We want this angle. So what do we know so far? Well, I have this blue line here, and I know that it's 39 degrees. So here are my two parallel lines, so 39 degrees. So I can say that it's a parallel lines cut by a transversal. So if this is 39 degrees here, that means this blue is also 39 degrees. And so that gets us closer to our bearing. The last thing we need to find then is actually angle B inside of our triangle. So we could go ahead and use a law of sines to solve for angle B. So sine of b over b equals sine of a over a. So let me multiply by my side b to both sides. So b is 8 times sine of a, which is 132 degrees, over side a, which is 18.34. And then if you plug that all in a calculator, angle A, well, you would do B and then sine inverse, right, to solve for it. So sine of B, and then do sine inverse. When you do that, B is approximately 18.91 degrees. So that isn't our bearing, that just gets us the angle inside of our triangle, 18.91 degrees. So in order to find the bearing then, we're going to add 39 plus 18.91. So 39 degrees plus 18.91 degrees will equal 57.91 degrees. And looking at the direction of from B to C, that is in a southwest direction. So therefore, this is south 57.91 degrees west.